for the work. So it's unique in that way. I will share the screen. Okay, so I guess we're ready. Andrea?
Yeah, go ahead, Mohammed.
Okay. So I would like to introduce our speakers today. Dr. Naveed Sharwani, who's the chairman of Premise AI. And Dr. Naveed has been, Dr. Sharwani is a seasoned executive and seasoned veteran of the chip design industry, 35 years of either design expertise, management, as well as entrepreneurial experience. And he's one of the people that are able to raise significant amount of money for investment for semiconductor companies, over 15 rounds from different VC companies. And he is a leader in the field and recognized in multiple on multiple directions. And he's the chairman of Premise AI. And then our second speaker is Hans Baumeister. He is a pioneer in the AI area, and he worked in multinational companies and startups around just with a focus on operational improvements and excellence, and as well as the solid expertise in in ASIC design, RISC processors, as well as semiconductor IPs. For machine learning and AI, he's been driving innovation in the market as a founder of Neurono, a company, and which had demonstrated his ability to drive and change in the market, specifically around the AI. So I'm going to hand over to Dr. Naveed.
All right, Mohammed, thank you very much. First of all, I'd like to thank Mohammed and Andrea and the team to put together this webinar. And in particular, Mohammed's work in eFabless, along with Mike and others, for really popularizing chip design amongst students and researchers. It's pioneering work. And the work that I'm a very big supporter of from day one, when he started somewhere in 2008, and I met him for the first time. I believe that was in Open Silicon. He walked in and he said he has an idea to democratize chip design and tape out. It has been a long journey, but he has done wonderful. Very proud of him. So I think the comments I would like to make is that when I started in chip design was in early 80s. At that time, automation of chip design did not exist. Most of the chip design was done by hand. And when we started doing, many of the people who used to design was basically mask designers. And they used to tell us that chip design can never be automated. And this is what I heard repeatedly in early 80s. Of course, there was an explosion of chip design tools from mid-80s to by 1995. A huge number of companies came into, this is the time when Cadence and Synopsys and Mentor Graphics grew up into companies, Magma and many Dolphin and many other companies started. And I think explosion happened. But if you look at the history from that point onward, from 1995 to today, it has been a maturation of the design tools, optimization of the flow. But in that sense, nothing major has happened in the sense dramatic in terms of algorithms and things like that. So I think about 2 years ago, when we started looking at generative AI and what it can do for a chip design, that's when I felt that maybe in the last 20 years, something different is happening now. And I truly believe what is happening. So the journey of generative AI use actually started in a company called Rapid Silicon. It's an FPGA company. And our goal there was to build something that our customers don't have, makes it easier for them to program FPGAs. So we used to call that effort low code, no code approach towards designing FPGAs. As soon as the LLMs came up and ChatGPT came up, we realized that this low code, no code can actually become really no code, and we can start moving and start designing something that can help people who design FPGAs much, much easier, almost all automating it. And that's when this tool called Rapid GPT was invented in Rapid Silicon. Very soon, they started growing and became more and more capable. Eventually, it was decided that we should spin this off from Rapid Silicon, and it became a new company called Premise.ai. So in the journey in the last year and a half, what I have noticed, I believe generative AI is going to be the next major change in the whole chip design industry. Why is that the case? Because as we have explored and talked to a whole bunch of customers all over the world, we have realized that there have been a lot of tasks that we have been doing in chip design, which are fairly mundane. They can be easily automated using generative AI. And Hans will talk about many of those. But beyond that, I think generative AI capabilities, if you go towards the future, can go to a point where it can become a very good consultative agent, helping senior designers. It can even start writing specifications. It can find holes in specifications and issues, things like that. It can do very large number of tasks which are quite tedious, not very creative, and can take over. So I think generative AI is going to go down the path we went down with autonomous driving. We will have something like maybe D1, where we mundane do simple tasks, then a level called D2, where we start automating, D3, when we can start doing simple chips and doing a whole flow perhaps. D4 might be a session where it can do complete specification of a chip and design the chip for simple chips, and eventually a D5 system, which can do very complex specification and full design automation, maybe 5 or 10 years from today, or whatever the timeline may be. So to me, generative AI has a possibility of really bringing a lot more people around the world into chip design, which I really think is very important for democratization of silicon. And I think the other thing, it can simplify teaching, learning, and improving the cost effectiveness of the chip design. So I really am a very big believer of generative AI application into chip design. And I hope in the next 30-40 minutes, Hans will be able to show you not only what are the possibilities in the future, but what we can do today. And I believe you'll be amazed with what we can do today. So with that, I would like to pass on to Hans to take us through the capabilities and potentially a demo of what Premise AI can do today.
Okay, great. Thank you very much, Naveed, for the introduction. Thank you very much, eFabless, for hosting this webinar. So as mentioned, my name is Hans Bouwmeester. I'm happy to present today on Premise AI, and specifically our tool called Rapid GPT. So I have a few slides which I'll share, but I think most of you are probably interested in actually seeing generative AI in action, right? That's really where, ultimately the proof is in the pudding. So I will, show a demo, really, going into several examples. It's impossible to cover the whole world, of course, of examples, but I'll go into several examples of what generative AI and what Rapid GPT is and how it adds value. So let me share my slides. So as we dive in, it's really incredible how far generative AI technology has come in the past, few years, right? It's only recent. Many people didn't know about OpenAI and ChatGPT until recently. We have been at it considerably longer. deploying large language models towards hardware design. But also for us, it's really accelerated recently to the point where we released Rapid GPT, which is like I call it like a pair designer or collaboration type tool. It's very different from a traditional EDA tool, which you configure and then you start it and then you get results. You need to interpret those results and maybe you have to restart the tool. But it's very different in that this is much more something which is with you. It's an assistant. It helps you. It's always there for you when you need it. So this is Rapid GPT today. And the way we see the future is really for AI agents to become an integral part of the hardware the design team. They become pervasive. They make recommendations, suggestions. They do make mistakes also that will go down over time, absolutely. But it is a very human-like type of machine. And ultimately, the generative AI can even take over management-like roles. If you look at where we come from in a way when it comes to abstracting a design, then in the 70s we used to design using transistors. At some point we realized it would be good to bundle these transistors into gates to create a library with certain logic functions. And it's not like we did away with the transistors, but we built a layer of abstraction around the transistors. Now, similarly, we progressed from using RTL to design becoming more like playing with blocks, integrating IP into an SoC type of environment, to more recently, transaction level modeling and system C type of approaching. And then, of course, I think everybody can recognize what the question mark is, and that's a really natural language. And it's not like natural language will replace Verilog. That's not the intention. Maybe it reduces some of the Verilog usage, but it's not the intention to replace it. Just like logic gates haven't replaced transistors, right? It's a layer around it. And we foresee that natural language can be used for many different tasks. And, in a way, we divide the world in sort of like 3 value adds, which generative AI and which our tool called Rapid GPT brings to the industry. And the first one I would say is the ability for generative AI to create something. It's really, we call it creativity drives innovation. The creative aspects, like ChatGPT can generate a poem. Rapid GPT can generate many things. The obvious one is, of course, RTL code, right? But don't forget, it can also generate architectural specifications, or it can generate a test bench with test cases, so it can help you with verification. It can also generate an integrated environment of IP, right? Such that you're designing with IP. So that's the creative aspect. Now, generative AI also has the interpretive aspect in that it can look at something and it can summarize it, or it can compare 2 things. It can really analyze. And we capture that as, knowledge equals power, because effectively it enables you to do Q&A with the AI agent, teaching you things you didn't know, or you want to know, or you want to have explained. And this can be things like, like just asking, statements, or, how do certain constructs work in your design language, whether it's VHDL or Verilog or whatever, right? But it can also be that you ask questions about the design, like what does this function do? And the agent will teach you, will basically tell you and help you explain what a certain function in the code actually is for and what it does. And then the third one also is, it can help with an IP catalog. So we actually in RapidGPT, we marry the large language model with it's called a RAG, a Retrieval Augmented Generation module, or knowledge base. And now we can really leverage the agent to know about intellectual property. And you can ask questions like, which algorithm does this IP implement? How do I configure it? What does this port do? What does that port do? Etc., etc. And the last one is kind of an interesting one because it sort of falls out of the first two, but we think it's important enough to separately mention it. And that is that the generative AI also is able to start executing some tasks which were very hard to automate before. And I'm thinking of, those, especially tasks also which nobody likes to do. They're sort of the automated type tasks, but there are no tools for them today, simply because the capabilities were not there yet. An example is the ability to write documentation or to augment code with comments, or on the architecture side to write specifications. Now, of these, this set of examples, I'm showing all the ones in blue during the demo. I'm not showing the IP side simply because you were limited in time, and also because a lot of the attendees I know are interested in the Chip Ignite AI Challenge, which is coming up, which is starting. So I thought I really show examples in that context. So we offer a number of engagement models for RapidGPT. We have a low entry level free tier. So go to our website, sign up, play with the tool, try it. But also we offer a pro with additional value add, which is a monthly subscription, which is also provided through our website. But we also offer an enterprise offering. So contact us if anybody is interested to learn more about that offer, because a lot of questions we get is related to, data security, right? Privacy of data, but also about the ability to enhance RapidGPT with our customers' IP, our customers' EDA tools, and even our customers' methodology. So this is RapidGPT in a nutshell. So it offers these capabilities. The ability to create, language like Verilog or VHDL system Verilog. We offer the ability to do verification tasks like creating a test bench with test cases, and actually to start with a test plan. We have a feature called auto review, which is really where RapidGPT looks at your code and sees if it can find any errors, any issues which need fixing. We spoke about the ability to do commenting code, so it's a very useful feature. I'm sorry, getting all excited here. It's a very useful feature for if you receive code from somebody else and it is not really well documented or commented, you can ask the agent to look at the code, and RapidGPT will actually add the comments. I will show that. And the last feature is a feature to, if you have a set of projects, to actually automatically generate a set of documentation. So it looks at all the project files, and it'll create a comprehensive set of documentation, which can be the starting point for editing your documents. It's not meant to be immediately final, but it's really, it gets you like 80% there, that all the ports are mentioned, etc., etc. Now, a question we often get is like, okay, but why wouldn't I use ChatGPT, right? So here are some of the answers to that. So RapidGPT, we really specifically trained it for hardware design. ChatGPT can certainly do some hardware design, but it's simply not very good at it. So we spoke about the knowledge base. We offer the on-premise deployment for enterprise customers, but also we have integrated RapidGPT fully into an IDE, an integrated design environment. So there's no need to copy and paste code, right? Which you would have to do, and if you use ChatGPT, for example, or likewise tools. There's many now. We have the ability to generate documentation we spoke about, and also we have a way to accept and propose changes to the code. So I'll show that during the demo. Also, I'd like to mention for those participants of the webinar who would like to participate in the Silicon AI Challenge, more information is on the eFabless website. Please contact us because we would like to very much, as Primus AI, enable you with a free license. For that, all is needed is an API key, and you can contact Diana at primus.ai for information on how to get this API key. And that API key will enable you to do everything I'm about to demo. So that really is, it's comprehensive in that sense. So with that, I'll actually jump into the demo and go from here. So the first thing I'd like to talk about, and what I'm showing here, is how to install RapidGPT. So RapidGPT is an extension to VS Code, which is a Microsoft IDE. And you can see that you just install it like any extension in VS Code. It's very easy to do. And all that's needed, as we spoke about, is to install this API key. It then gives you a chatbot. So you see on the left side of the screen, you see the chatbot, and you can ask any questions similar to tools like ChatGPT. So in this example, I just asked, like, tell me a joke. But any question works, of course. So next one I'll show is, a more hardware-related question, right? And this is a good example where, RapidGPT can really help junior designs, explain things about, about hardware design in general. So here's an example, like, what is metastability in a flip-flop? And it explains, in detail, how that works. You can see I go pretty fast, so maybe I'll slow down the speed a little bit. So what's important is the prompt engineering. It's really how you instruct the tool to which command do you give the tool? What English language do you use? Now you'll notice that I use very short prompts in this demo. That's that's more because I'm lazy and I'd like things to flow, of course. But in reality, think about, and this is what's on our website. It shows the prompt engineering guidelines. Really think about how you instruct RapidGPT, because a change in your instruction can really make a difference. So next what I'm doing is creating we'll just do a very quick design of a counter. So I'm creating in the editor window, I'm creating the counter, and I'm showing how, very simply, you could just use a comment and press enter on the comment, and it immediately will submit the request to RapidGPT and start generating the code for this counter. So that is a very quick way to start and to play with RapidGPT. So next one I'll show is the auto comment feature. I press the auto comment command, and now automatically the tool is looking at the code and will add the features. Now what's important here is that the differences are actually proposed as changes. You don't have to accept them, but you have the option to, for every change to yes or no, accept it. And note how now we have a nice header with the inputs, the outputs, a description, and also more comments in the code. So next I'll show how you can now interact with the code using the chat interface. So I'm asking like, okay, we have a counter now, which is a 10-bit up down counter, but I'd like it to be saturating. When it reaches the high or the low maximum, the limit, then it needs to saturate rather than wrap around. And you can see now that we're effectively interacting with the code on the right, asking the question, and it relates the answer to the question we just asked. So you can see that it now has the logic to detect, are we at the max or are we at 0? And if so, then saturate rather than wrap around. And I'm accepting these changes such that now we have a saturating counter. Now, next I'd like to show is really, what I call hierarchical composition, which is really like, okay, so how do you create a design using lower levels designs, right? Because you want to solve a bigger problem by solving smaller problems one at a time. And the example I'm giving here is for a multiply accumulate circuit. So you can see that I first asked like, okay, create a Verilog for a multiplier. You can see that I got some questions like, well, what type of multiplier would you like? Signed or unsigned, combinational or pipelined? So I gave answers to those questions and get now the Verilog for a signed multiplier. Now, similarly, I'll do that for an adder. Because, of course, for the multiply accumulate functionality, we need the multiplier next to an adder. And then when that's done generating, I will add the module for the adder to the editor window, such that now we have a file with two modules in it. And so next now is to really meant to show how we can create a higher level design which instantiates these lower level designs. So this is really the divide and conquer, the separation of concerns type of approach, which you would normally do as a designer. You wouldn't expect that you give one command, one input to the tool, like, generate a very complex system from scratch. No, you would really divide it into sub-problems and then tackle these first. And then, have the higher level task fixed by having these lower level problems solved. So you can see I asked it like, okay, create a multiply accumulate using the signed multiplier and the signed adder circuits. And you can see that here's our max circuit. You can see it instantiates the multiplier, it instantiates the adder, it adds the register for the accumulate storage, and that's effectively our multiply accumulate. So next we'll go a little bit more complicated in a way, in that I'll show how to design a UART and how to do a refinement, getting this UART to become more and more feature rich, if you will. So my first question is simply like, okay, propose RTL, and you can see that I get a response like, yeah, okay, but that's very open-ended. What kind of, how many data bits would you like? Would you like a parity? How many stop bits? You don't have to answer these. If you don't, you'll get an assumption from the tool. But generally, of course, it gets you to think about like, hey, what is it that I really want, right? So I'm answering here like, 8 data bits. And what did I answer for the parity? No parity and 1 stop bit is what I answered here. And you can see that it generates the code for this UART implementation. Now, let's say that we made a mistake, or maybe, the agent made a wrong assumption in that maybe it assumed that we wanted no parity, where actually we did want an even parity. then, after we integrate it into the editor window, we can now ask it to change it. And the change I'll make here is to ask for, like, please change it to an even parity rather than a no parity. So this is really the interaction to refine the implementation as you go. So with that, now we have a, still basic UART, with an even parity support. And you can see here that the state for the parity support has been added now. So we'll integrate that and accept the changes. Again, you can choose whether to accept changes, because we wouldn't want Rapid GPT to just, change your entire code. It's really better to review the changes proposed such that you agree with what the tool suggests for changing. Now, this is still a very bare bones UART. So one, can now ask questions about it. Like, if you look at UART and you see that there's something called flow control, and, we may wonder, based on learning that, like, okay, does this UART implementation implement flow control? And you can see that the answer is no. And also the tool teaches you that there are actually two types of flow control you could consider, and that is, doing it in hardware or doing it in software. And so what we do here actually is we're asking, like, well, let's change the implementation to support hardware flow control. And then it knows what to do, in that it added you can see that it explains what it did. We like that also. It does not just, we configured it such that it doesn't just generate the code, right? Like, here you go, here's your code, right? No, it actually tells you what it's doing and why, right? So it's really saying, like, okay, I'm adding an RTS signal, which stands for request to send. Such that really, like, okay, here's what my code is changed for. You can also see that it adds a buffer, and you really have to look at it for some time. But it actually does implement a buffer, but not fully, and we'll come back to that later, because actually I wanted the buffer to be external rather than internal. You can also see it here, like it introduces a simple buffer management concept. So in other words, it's not really a full implementation. It's still at the conceptual level. Then, next there is also a feature for a data overrun detection, right? What if the transmitter keeps feeding data into the receiver? We are the receiver here, and we're not ready to receive it. So, we'd like to have that error detection being part of the UART as well. And this shows how that's added to it. So I'm accepting these changes. You could actually see that the first change I accepted was one where it proposed to change the module name, which may not be desirable. So that what actually I did was I changed it back to UART receiver without the overrun. And then one more, so really to show, like, the stepwise refinement. Our UART is becoming smarter and smarter by equipping it with more and more features, right? I'm adding support for frame error detection. Also, you can note that I add the command, please make sure to include all logic in your response. That's sometimes a good idea, because sometimes it likes to say, like, well, this logic is like before, and sometimes that's not desirable. So that's an example of prompt engineering where you can help the the tool, RapidGPT, to really, do what you would like it to do. Just be specific in your requests, and you get a better response. So one thing also is that you may see this little garbage bin here, is that you always have the option to undo your last request and reissue it with making some modifications. Now here I'm showing the buffer, which is not really fully implemented as a buffer. So one thing I decided to do actually is to implement that, and I will come back to that a little bit later actually, to implement that as an external buffer. But before that, what I'm doing here now is I'm asking the question like, okay, let's just look at the code like sort of a human being. And if you look at the code, do you have any suggestions for improvement? And you can really see it can help you like think about certain aspects you may not have thought about. I think one of the very good ones here is like the error handling. Is we added error handling, but currently the code will assert an error, but it will only deassert it if you, let me pause the video for 1 second. It will only deassert it currently if you reset the module. That may not be desirable. So a next step could be, and it's actually suggested by RapidGPT, right, by the agent. A next step could be like, well, look at your code. Maybe you want logic where you can deassert an error signal if it occurred without necessarily having to reset the full block. So that's really a very powerful way where where RapidGPT helps you to think out of the box, outside of the box. Now, next one I'm showing is the auto review. And so one thing I ended up doing I changed the buffer. And when I did that, we spoke about this buffer, and I did actually change it, but I made a mistake when I did that. And when I click auto review, you can see that it actually found the mistake in that the buffer full was still an internal register, as well as also an input on the module. So that's the auto review feature, really helping you to look at the code. Does it compile okay? And if not, it tries to fix any compilation errors and also gives you other suggestions for the code. Now, last one I'm doing is similar to the counter. Just to finish our UART, I'm adding the comments such that we have a fully comprehensive commented UART. I just accepted all the comments. Maybe you would not want to have all of them, but you can, of course, choose that. But what's very important and very nice is that you get this header with the inputs and the outputs, and as well as a description. Now, one thing we've been doing is that we've sort of worked with the specifications in a little bit an open-ended way, right? We started with these very high-end questions like, I need Verilog for UART. Then we started adding stuff. We started changing stuff. It's easy to lose track of like, what is now really the spec for the UART? I apologize, actually. I'm running ahead of myself. But let me finish my thought here. Is you can ask a question where the agent, where RapidGPT will actually summarize all the specs for you, such that you know exactly, and I'll come back to it later. It's actually the next thing in the video, where you really know exactly like, okay, this is what I implemented, or this is what the code is doing. So we'll come back to that later, and I will go back a little bit, because the question I ask now is, okay, we have now the code, but we'd like to generate a test plan for it, right? Because we need to verify the code. So I'm just asking, please propose a test plan. And I think this is one of the very powerful aspects of RapidGPT, again, in that generative AI really is exceptionally good at thinking outside of the box. So you can see that it really gives a comprehensive test plan. And I would say if I would have a junior engineer joining the organization and I would ask them for a test plan, and I would get a thinking outside of the box, like, think about the basic functionality, the baud rate. It tells you exactly like, what test you need to implement, the parity bit handling, the frame error detection, the overrun detection, the flow control, the reset, stress testing for edge cases. If a junior engineer would come with a test plan like that, I would say like, well, hey, good job, right? You're hired. So what I'm doing next is I'm for one of the test cases, in this case, test case number 5. I forgot which one that is, but we'll come back to that later. It's a good idea to take each test case individually and create an individual test bench for each of them. And I believe this one is actually for this is for the overrun error detection, which is case 5. And you can see that we get the test bench, which instantiates the module. It initializes the signals. It applies the reset. It generates the clock, and then it applies the stimuli to the unit under test, and really gives us a pretty comprehensive, definitely a very good starting point for a test bench.
Hans, I don't mean to interrupt, but I just want to make you aware that we have about 30 questions.
Okay, yeah, well, I'm almost there. I'm getting there.
Okay, perfect. Thank you.
I can also change the playback speed a little bit. I'll go to 1.5 times. What I'm showing here is to just ask a question about the test bench. Again, this is very useful, like if you forgot, or if a language which is used is new to you. So I'm asking here, like, what does the timescale directive do? I'm also asking a question like, what is this task here, to show, like, you can ask it to explain features in the code. And it'll exactly say like, okay, this is what this task is doing. And then last, I can even go to 2 times. And because essentially we already spoke about that, because what I'll do next is actually ask for a set of specifications. I think there's one more test bench I'm generating here for another test case. So I can actually jump ahead a little bit. And just to make sure we have ample time for questions. So this is another test bench which is generated in a similar way. And also I'm saving that one. This is the other test bench, because what I wanted to show is what we spoke about is also, yes, is coming now, is really like what we spoke about, like I'd like to see a set of specifications. And this shows that, when it comes to generating something, never forget, you can also just generate English. It doesn't have to be RTL code. And you can see here that we get a comprehensive set of specification in English language. So, it tells you, like, again, what the outputs are, the parameters, the functionality, a description. So it's very quick way to learn about, what is it doing and why. So next, what I'll show, I'll go to 2 times playback speed again, is the ability to do automatic generation of documentation. So it's the AutoDoc feature. And I'm just asking, like, how does it work? You don't have to go to the manual. Our manuals are integrated into RapidGPT. So it effectively explains something out of our user manual. And then next what I'll do is I'll generate documentation for the project, which is the UART with the test benches. And it generates a docs directory, which I'm going to now, which has a install instructions and a make file. And when I follow those instructions, I install the required Python code, and I do a make HTML. It gives us the website, and then browsing to the website, index.html, you can see that we now have the starting point documentation completely, human readable and presented as a website. You can see the UART receiver module and test benches. Here's the description for the receiver, and here's a description for one of the test benches and another test bench. So everything we just created is summarized. So next what I'm showing, and this is the last before we go to the question, is I thought there will be an interest potentially in that, many of the participants would like to participate, or in the Chip Ignite AI challenge. And you may be familiar that eFabless has a little video showing an example of you using generative AI for a certain specification. And what I'm showing here actually is that that specification, which is, let me go back 1 second here.
Almost a year old to the day, Hans.
Oh, is it? Oh, Andy, yes, because I saw you did that video. So, Andy, here's actually the instructions you gave, right? At the time. So it's about, Verilog for a counter which is connected to an, or is actually an APB client, right? So it's connected to an ASIC peripheral bus. So I'm just asking the question. I did this. This also shows, by the way, how I just opened the file, and that file is associated with the chat. So, I just opened the file, and because I did this earlier, it just remembered, it knows the questions I asked at the time. Now you can see here the answer of RapidGPT. Again, it's more than just code. It also gives an explanation. And also I noticed that there's a buffer. It asked the question like, would you like to have this buffer internal or external? So that's a very good consideration, right? I'm asking it to rewrite it a little bit. And ultimately, I end up with, with the code on the right, which would still need to be verified, of course. I'm also asking a question here like, hey, what is APB? Just to help us understand like how the AXI peripheral bus works and what it does. So I'm accepting the changes which were proposed. And I think, last is I added the comments, and here's our counter with APB. So with that, Andrea, we can go to questions.
So Andrea or Mohammed, do you want me to just read through to try to get through them quickly?
Yes,
Yeah, go
please.
ahead, and we're gonna need to go rapid fire.
Yeah, okay.
Go
So
ahead.
the first one up is, can this tool generate RTL from a netlist? Somebody's asking, can they reverse compile code?
The honest answer is I don't know. I'd love to try. That's actually, it's very interesting in that our users encounter ways to use RapidGPT in ways we haven't thought about before. Some ways it might surprise you what it's able to do. So I would say, try it. I haven't tried. I'd love to try it.
Got it. Is the tool generating synthesizable code all the time?
It doesn't have to, like in the case of course, if you ask for a test bench, it will be behavioral, and it knows that because you're asking for a test bench. You can be more specific and ask for synthesizable code. And also the auto review will help to make sure that it's synthesizable. Sometimes it may help to, in the instruction you give, to explicitly use the word synthesizable to make sure that it becomes synthesizable.
Perfect. A quick request we got multiple times. Is it possible to share the PowerPoint that you showed earlier?
Yeah, that's no problem. We can share that.
And can we get it to optimize existing code? So can we submit code and have the tool provide optimization suggestions?
Oh, absolutely. I think I showed that in the sense that you can ask it like, just look at my code. What do you recommend? Do you see anything wrong? Do you see anything that can be optimized? And it can really surprise you with its out-of-the-box type thinking. So yes, I mean, your mileage may vary. In that sense, RapidGPT is like a human being, right? but it can really, the power is really the out-of-the-box thinking. It may really alert you to things you didn't think of.
Fantastic. We have 33 more questions, so I'm going to try to do this pretty quickly. Is the tool capable of SOC integration, block integration at the top level?
Yes, absolutely. We actually did and I showed it with the Mac, which is a simple example, but we actually did an SOC using a RISC-V and an AXI bus and AXI peripherals, really integrating one at a time, integrating them into a very high-level subsystem. Yes.
To Faisal, yes, the presentation will be available after the call. Is the solution fully deterministic, or does it vary if I run the same questions twice?
It varies.
Yeah.
That is both the power as well as, something which sometimes can be a little bit confusing. Sometimes it helps to just ignore an answer and ask the question again, or maybe, fine tune the way you ask the question.
But if you get to the point of having a test bench in Verilog, the result of running that Verilog against the test bench is presumably deterministic, right?
Of course, yeah.
There you go. ARM APB spec is used. Is the IP library installed as part of Rapid GPT or part of your training?
So the IP library is installed. We currently have an IP library with FPGA IP. It's less applicable to the Chip Ignite Challenge, but we also have the ability to load the IP library with customers' IP for enterprise customers. So contact us if you'd like to learn more.
Got it. Question about analog design with generative AI. Is it possible? Yes, it's possible, and there will be a new challenge on analog design with generative AI. There's already multiple people working on it. If you're looking for a pointer, Berkeley is the right organization to look towards. And there's a lot of research going on in that space. Can you tell us how you came up with the LLM science? Is this a dedicated new LLM or a tuned existing foundational LLM or your own?
So we use open source LLMs for the most important reason. That's the like I mentioned, the data protection for enterprise customers. We really want control over which data is used for training and make sure that there's no leakage there, right? That there's no concerns about intellectual property. So really to control the environment.
Got it. And then Chris Lee, I'm interested in knowing if we have a plan to expand this to generate Verilog 8 code.
There's no immediate plan, but in the long run on the roadmap, absolutely. We plan to support any industry standard type language you can think of. And even we're using Rapid GPT. We've trained Rapid GPT on a specific to a customer. We have a version of Rapid GPT trained for their proprietary scripting language.
Got it.
So in other words, we can really train it on anything we would like to. Yes.
Are you leveraging Grok's inference engine?
Not that I'm familiar. Let's say no, Andy.
not on Grok yet. You should think about it, by the way.
I'd love to learn more. So to the asker of the question, please contact me. I'd love to learn more.
Anonymous attendee, question for Hans. What is the competitive landscape right now? Who are the other people trying to do this, and how are you going to differentiate yourselves?
Yeah, so of course, some of the big EDA companies are also leveraging generative AI. But what's interesting is that we sit more on top of their tools. We apply their tools as part of our solution. And also we can thereby leverage open source tools. Also, they have holes in the flow, which we can plug thanks to our generative AI. And also, if you really think about it, generative AI will provide such a boost in productivity that in a way for many of our competitors, it is counter their business model if the number of EDA licenses they can sell becomes less. So in other words, we feel that we know that we're very well positioned, and really when it comes to other competitors, we know that we're ahead of them. And ChatGPT, as we spoke about, is a great tool if you want to pass the bar, right? But for hardware designers, Rapid GPT really is the way to go.
Are there static checks, compilation, limiting, synthesis, etc., that are supported today?
So auto review indeed is an example, right? Which is like using the deterministic tool under the hood to augment the call it the creative aspects of generative AI.
Is there an example of a complex project entirely made with Rapid GPT?
Yeah, so we spoke about the SOC, right? So that's an example.
Perfect. There are questions arriving as fast as we're answering them. We're now up to 54 questions. So give me 1 second while I try to run through a few more. Is Rapid GPT a wrapper on existing ChatGPT, or is it a completely different LLM, or is it an open source LLM similar to a question we answered before? Is there or are there updated designs that should be checked by an engineer as a result of this, or should we just expect to take the output?
Check and verify. This does not replace verification, but of course the agent can help you write your verification tests. But you need to verify.
And can this help us learn Verilog?
Absolutely, yes. I think I showed that. You can just ask, like, how does this construct work, right? What does time scale do? So yeah.
Yep. Do you support the importation of third-party IP?
We do for enterprise customers. So contact us for more information.
Yeah. Are there limitations or known limitations with the boundary of Rapid GPT currently that we should be mindful of while we're leveraging what currently exists?
I would say not really. I would say, try it and you'll find that it can really add value in areas you didn't think, and it can really accelerate your design. So in that sense, there are no limitations. In another sense, like, hey, this is not a brain which knows, it's not an oracle, right? I mean, so yeah.
Fantastic. And is it going to let many designers go out of business?
I think for the time being, it's really augments designers. I mean, so no, not yet.
I think what you're going to discover is that there's an almost infinite capacity in the world to swallow new silicon, and the barrier to more new silicon happening has been the number of designers that are skilled in this world and the number that graduate every year. So if you get trained on new tools, you'll be more productive.
Yeah, exactly. I subscribe to that. It's related to, it's referred to as the design productivity gap in the industry. So yeah, absolutely.
The limitation,
I wouldn't be worried.
Yeah, the limitation is what the industry can afford based on a required shareholder return. And as soon as we increase the productivity, there will be more chips. And are you currently fundraising? How many users are enterprise users? That's somebody who wants to give you money. And that's also anonymous attendee, by the way, who puts up very good questions every time we have a
anonymous money, Andy.
Yes. And so, yes, you're fundraising. I should take that as that's a Naveed question. Yeah. And does Premise AI think about NVIDIA as a potential partner or competitor?
I would say both. I mean, the market is so big at the moment. There's so many solutions. Of course, we need NVIDIA as Premise AI to accelerate our LLM agents, right? So from a hardware perspective. So, hey, nothing wrong with NVIDIA. We use them all the time.
Perfect. And can we generate Verilog A code with Rapid GPT the way it is today?
I don't know. We would have to try.
I'm typing that answer, not tried yet. I'm still getting questions.
Yes, exactly, not tried yet. I would assume that it has basic knowledge based on the training set, but yeah, we would have to really try it.
Is there a token limit or a time limit to the free version that you're proposing to provide to the Gen AI contest contestants?
The time limit is limited to the time of the contest, right? So as long as the contest run, the API key will work. And there's no token limit, but we are assuming, of course, that everybody behaves, right? That there's no robots generating tokens, right? And hitting on our server.
I wouldn't assume that based on our prior experience. We've got a lot of people who are very good at automation.
So let me answer it this way, Andy. Are there currently any rate limits which we apply? The answer is no, not currently.
There you go. You might discover that you need them next week.
But that would be, in a way, that would be good news, right?
Yep. What are the limits of the free licenses, and is there a plan for a freemium business model in the future with a student version or a free version as an entry level?
That's effectively our model. So our model is, and we seek to keep this model towards the future, is to enable students to use RapidGPT at no cost. Yes.
Can RapidGPT help with backend, physical synthesis, CDC, STA, DTA, etc.? Is it able to work through the other portions of the flow yet, or is it solely front end as far as synthesizable RTL?
Focus at this moment in time is on the front end. We have products for the back end on our roadmap. Of course, you could ask it some back end questions, but it's not formally supported currently.
Got it. We are doing very well, but the questions are still coming in. And does Primus AI have future plans to work on ASIC backend? And then the same conversation. Yes. I apologize, we hit it again. And can we solve complex issues? We already hit. And can we also generate RTL code and netlist with this generative AI? And the answer is yes, obviously, based on the conversations. And Ahmad Katab, is it wise to shift career now before it's too late? Smiley face.
I won't answer that one.
It's wise to become proficient in AI and understand what it's going to do to help you and be on the leading edge rather than the trailing edge of that curve. Yes.
I think that's an excellent answer. Is learn to use generative AI to your advantage. That, yeah. I think is indeed the right answer. Yes.
So in general, you can say engineers or developers who use generative AI are going to replace engineers or developers that don't use generative AI.
There will be a very small number of spaces where not using generative AI is feasible from a career perspective in a few years. Very small.
Move up in your abstraction level, like the
exactly.
arrow I showed. That
Yep.
will be my advice. Yes, yes.
And is it possible to log the interaction with Premise AI for the purposes of reporting for the Gen AI challenge? So can I get a log of what I did when I'm interacting with the tool?
Yeah, there's actually a file where the chat history is stored in a JSON format, and that can be, I think, Andy and Mohammed, can be the way indeed for users of RapidGPT in the contest to communicate the chat history.
I'm literally attempting to get new questions. Could you please elaborate on how it was trained? Did you alter the LLM? Or is it a foundational model, third-party foundational model, or your own model?
So it's a third-party model which is trained by us using open source, for example, Verilog examples, but also VHDL and what have you, which are available online. Yeah.
Perfect. When using RapidGPT, can we get a log file? How does prompt engineering guarantee or help at 100% synthesizable code? What would I need to do to get 100% synthesizable code?
Yeah, so we have trained the model in such a way to make it, to make it perform as good as we can when it comes to synthesizability. Sometimes you find something where it's not fully synthesizable, in that it might have a register which it declares and immediately it assigns an initial value, and then you can just ask in the prompt, like, please fix that for me. So that's I think the answer. You can also, another way is, if the synthesis tool gives any errors, you can actually feed those errors back into RapidGPT, just copy them in the window, and it'll analyze it and fix the error. So that's another way to do it. But generally, our experience is that most of the codes generated is synthesizable.
Questions about scope of the code generated. Does it handle multiple clock domains and clock domain crossing? And also, is it capable of handling a different question? Is it capable of handling UPF?
So the answer is yes to both of them. UPF is still in the basic, in the beginnings. Let's see, the first question. Oh, yeah, but clock domain crossing, it understands clocking. You still need to be careful. I mean, check but verify. Because, of course, clock gating is a quite complex type of approach. But yes, it does understand the concept of clock gating. And I've used it also to do, actually, in this example, it does a clock gate, I think, on creating the hold for the counter. for the chip ignite example.
And what's the context length, or how much of the code and conversation history will it understand or continue to understand as my design evolves? And is there an upper limit of the kind of design size I can work with in the tool?
Yeah, so the context, of course, from a model perspective is limited. I believe it's 16K tokens. But what we do, we deploy techniques that if the context window starts overflowing, that we mitigate it. So we summarize the oldest information such that we still keep the performance as good as it can be. So as a user, you won't notice it. You'll never get an error message like, sorry, the context window is full. We mitigate that.
Fantastic. Did you benchmark it versus other LLMs like Verilog Eval? Did you use any of the public benchmarks to understand how good the code generation is versus kind of the best industry tools today?
Yeah, we have an internal benchmark set, and we benchmark, for example, against ChatGPT because of it being, the open source type of reference. So the answer is yes, we benchmark all the time. For specific results, I would say contact us and we can discuss more.
Perfect. And I think that specific question came from Mohammed Shalan, who's just developed a new Verilog LLM, and he'd love to get his Verilog LLM tested versus the industry to see where it falls.
Okay.
I think he's hoping to announce a paper on something in a week or two. And Subhash Arya, we use Rapid GPT for, is it possible to use it for photonic integrated circuits? And if so, does it have some kind of comprehension of what photonics are?
It hasn't been specifically trained on the photonics side. So it'll know the basics about photonics, like what's part of the general training set. It's on our roadmap indeed to specifically create solutions towards, for example, photonics or towards chiplets or towards analog, etc., etc.
And how efficient is this tool when it comes towards resource utilization? Is it capable of being run on something like a phone or a tablet, or does it require, PC, 64 gig RAM? What kind of hardware platform should we be shooting for? So
yeah, it requires a server with a decent amount of VRAM, graphics memory, multi-core CPU. It's a single server it can run on. Of course, that's the back end. I mean, the extension itself, the VS Code, is the front end, and that will run on anything which Microsoft runs on.
Yeah, so the front end that the user sees, assuming that they're not deploying enterprise, will run literally on their tablet or their cell phone.
That's right.
Got it. Okay. How will this impact the VLSI industry in terms of, this is a thread, by the way, there's about 10 of these questions. I'm going to ignore this one. Will the window, the LLM, can it remember the code for consistency from prior interactions? So when I'm interacting and I've changed something and modified, am I able to talk to it about prior code that it developed or prior functions that it developed?
Yeah, so currently the way to do that in RapidGPT is to actually bring the prior code into the editor window and use that as your starting platform, which is a very powerful way and really recommended to use. Is just put it in your editor and all of a sudden you can ask questions about it, or you can ask it to change it. You can ask it to generate the specs, to generate comments, etc., etc. Yeah.
Are open source code contributions possible? Have you guys made any of this available publicly, and would you like, or are you open to people contributing to help grow it?
So not currently. Let me keep it to that. Not currently.
Yep. Fine answer. And I'm trying to move down to get the last couple here. There's still 22 new questions. We're up to a total of 73. Most questions we've ever had. And is it capable of analyzing waveforms or running simulations inside of the window?
So we have in the lab, we have a version we call Auto EDA, which really is enabling the user to control the simulation tools from natural language. And that actually also indeed brings in waveforms into VS Code. I would say contact us for more information. We can demo it, we can show it, but it is not publicly released yet.
Thank you, Hans. I'm trying to answer questions in parallel in the background that I can type the answer for. Does this understand or can it comprehend timing issues? So for example, is it capable of doing a timing simulation? It's related to the prior answer, not yet released. It's something you guys are working on in the background. CDC conflict resolution, same answer. Mohammed Faisal, for Chip Gen AI design challenge, is the API key that we can generate just by signing up with an email ID and choosing a free plan, is that sufficient, or are you guys proposing to give away some other level of access for the Gen AI challenge?
Yeah, so we need to figure that out. Once the submission there is a deadline tomorrow for submitting the initial proposals, and we would like to get these submissions, and we'll request the API tokens from, or have them register and get the elevated to pro on premise.ai.
Multiple people love your front end, but would love to use their LLM and have asked, is it possible for us to substitute our own LLM with an API key into your back end and have your entire architecture on top of my own LLM?
No, sorry.
I was waiting for that. Okay, and there are still 20 questions, and it's going to take us another probably 30 minutes at current rate to go through them. So I'm going to suggest, Hans, that you and I go through those offline and try to provide answers. It's probably better than holding everybody for another 20 or 30 minutes. Thank you, Mohammed. I'll hand off to you and Naveed to wrap. I think that was absolutely fantastic.
Well, thank you very much, Hans, and thank you very much, Andy, for working on the questions, accelerating them, and thank you very much, Naveed, for coming in with the Premise AI to share the Rapid GPT experience. And as Andy said, we're going to work on the questions offline and provide them in our generative AI channel that is around the challenge. So if you could stay tuned for that. And also, I think because we have the email addresses for the people who registered, I think we can share the Q&A answers directly to you. So thank you, everyone.
Okay, great. Thank you so much, Mohammed.
Thank you. Thank you very much. Take care.